This video will encompass different examples on calculating ionization energy or identifying similarities between successive ionization energies of an element and its electron configuration. To begin with, ionization energy is basically defined as the minimum energy required to remove 1 mole of electrons from 1 mole of atoms in its ground state. To calculate ionization energy, we use the formula E equals hV, where E equals energy in joules, h equals Planck's constant, and v is velocity. Velocity can be determined by the speed of light over the wavelength. Planck's constant is equal to 6.626 times 10 to the negative 34 joules per second. In the first problem, we must determine the energy in joules of a photon of red light, correct to 4 significant figures, given that the wavelength of this photon is 650.0 nanometers, and the speed of light is, in this case, E equals h times c over the wavelength, which gives us the following. Thus, the energy of the photon is equal to 3.056 times 10 to the negative 19 joules. The graph below represents the successive ionization energies of sodium. In this example, we will state the full electron configuration of sodium and explain how successive ionization energy data for sodium is related to its group number. The configuration for sodium is: the graph conveys that there is a relatively big jump from IE1 to IE2 and IE9 to IE10. This trend is equivalent to that of a group 1 element because after the first ionization, the atom will have a full valence orbital, and likewise for after the 9th ionization.